In this question, we determine the curvature of the helix traced out by the vector valued function. That is, r of t is given as 5 cos t, comma 5 sin t, comma 3t. And we'll be replacing this curvature formula given by this curvature represented by k. And this equals absolute value or the magnitude of the cross product of r prime of t and r double prime of t. That is the cross product of the first derivative of this function with the second derivative of the r of t, and this all over r prime of t magnitude q. So let's see how to do this. So first we have to determine this r prime of t. So r prime of t is basically the derivative of this vector valued function r of t. So we find r prime of t, and this equals we have to find the derivative of each of the terms inside the bracket. So the derivative of 5 cosine t, and this equals 5 times of derivative of cosine t is negative sine t, comma, and then we find the derivative of 5 sine t, and this is 5 times of derivative of sine t is cosine t, and then the next term we find its derivative, that is the derivative of 3t is 3. So we can put this in simplified form, that is r prime of t, and this equals negative 5 sine t, comma 5 cosine t, comma 3. Now we will find the second derivative since we need this in the formula. So we will find the derivative once again, and this is r double prime of t. Once again, we have to find the derivative of the terms inside the brackets. So the derivative of negative 5 sine t, I put this negative 5, and then derivative of sine t is cosine t. And then I put this 5 to find the derivative of 5 cosine t. I put the constant 5 and find the derivative of cosine t, which is negative sine t. And then the derivative of 3 is, which is a constant, is 0. So let's put this in simplified form, that is r double prime of t, and this equals negative 5 cosine t, comma 5 times of negative sine t is negative 5 sine t, comma 0. So we have found the two functions or the derivatives r prime of t as well as r double prime of t. Okay, so since we have determined the functions r prime of t and r double prime of t, we can find the cross product of the r prime of t with the r double prime of t. So let's do this. So I'm going to write down r prime of t cross product with the r double prime of t, and this is actually given by the determinant. So I put the unit vectors or the basis vector ijk, and then in the next row, that is the second row, I should put the components of the r prime of t, that is negative 5 sine t, and then 5 cosine t, and for k this is 3. Now I put the components of the r double prime of t in the third row, that is negative 5 cosine t, negative 5 sine t, and 0. We have to evaluate the determinant quantity. So let's do that. I'm going to expand along the first row to evaluate this determinant. So first I put this I vector, this is the I unit vector, and then I have to leave the row as well as the column represented by this I. So when I do that, I'll be having, or maybe I can just write down that 2 by 2 determinant. So this has to be multiplied with 5 cosine t, 3, and negative 5 sine t, 0. Then I have to put negative j unit vector. Then I have to leave the row and column represented by the j. Then I will get this 2 by 2 determinant, that is negative 5 sine t, 3, negative 5 cosine t, 0. And finally I put this k unit vector, and I have to leave the corresponding row and column represented by the k unit vector. So I will get negative 5 sine t, 5 cosine t, and then negative 5 cosine t, negative 5 sine t. So I have to evaluate this determinant. Let's evaluate this. So in the first we have this I. Now we have to find the diagonals, product of the diagonals minus the product of the other diagonal. So 5 cosine t times 0 is 0, and then we put minus, and then product of minus 5 sine t times 3 is negative 15 sine t. Now we will evaluate this 2 by 2 determinant. So once again, we calculate the product of this diagonal minus the product of this diagonal. So therefore, this becomes negative 5 sine t times 0 is 0. We then put minus. Then product of minus 5 cosine t times 3 is minus 15 cosine t. And then plus k vector. Once again, we find the product of the diagonal minus the product of the other diagonal. So this becomes negative 5 sine t times negative 5 sine t, which is 25 sine square t. Once again, I put this negative, and then negative 5 cosine t times 5 cosine t is negative 25 cosine square t. Let's simplify this. So this equals I vector times, we have a negative of negative, which is a positive quantity. So it is 15 sine t. We have negative j. And here we have negative times negative is, once again, this is positive 15 cosine t. And here we have k vector multiplied with, this is 25 sine square t. And we have negative times negative is positive 25, so it is 25 cosine square t. We see that from this term we can factor out 25, and when we do that, we'll be left with 25 times of sine square t plus cosine square t. And the value of this expression, this is a standard Pythagorean identity in trigonometry. So sine square t plus cosine square t, this can be replaced by 1 using the Pythagorean identity. So then this becomes 25 times 1 equals 25. So in the next step, I'm going to replace, after k, I just have only 25. So therefore, I can rewrite this or put this in simplified form as, I put the constants in front and then put the unit vectors later on. So it becomes 15 sine t times I, and this is basically a negative quantity. So I put this as negative 15 cosine t j vector plus this is 25k. You can put this as 25k, as we already simplified this. And this can be written in component form as, we will put this inside the brackets, that is 15 sine t. This is for I. And for j, it is negative 15 cosine t. And for k, it is 25. So we just put 25. And this is the component form of the cross product of the two derivatives, r prime of t and r double prime of t. And since in the formula we have to find its magnitude, let's find its magnitude immediately. So we know that this equals r prime of t. So it's basically the cross product of r double prime of t. And now we will find its magnitude. So therefore, we see that the magnitude of r prime of t, the cross product of this r prime of t with r double prime of t, and this equals, we have to put a square root, and we have to do the sum of the squares of the components. That is, we take the square of this 15 sine t quantity squared plus negative 15 cosine t quantity squared plus the last term is 25 squared. Let's evaluate this. And this equals 15 sine t quantity square is 15 square is 225. And sine t quantity square, we can write down this as sine square t plus negative 15 cosine t quantity square. The square of a negative number is positive, so this will become 225 uh, cosine t quantity square is cosine square t plus 25 square is 625. So this is under the square root. Now let's evaluate this. As we see that we have this 225 sine square t plus 225 cosine square t. So when we factor 225 from these two terms, let me put the square root, we will have sine square t plus cosine square t, and then we have this 625. So once again I can use this Pythagorean identity to simplify this. This equals 1. So 225 times 1 is 225. So I can put this now as 225 plus 625. This is under the square root, and when we add these two we get 850. So this is square root of 850. Now let me put this in its simplest form. I see that this is 85 is basically a factor of 17, or you can say it is a factor of 5. So I can write down this 850 as 17 times of 50. This is another square root. Now we can write down this as two terms, that is under the root of 70 times under the root of 50, and this equals under the root of 17. The square root of 50 we can write down this as 25 times, we can factor as 25 times 2. So this means square root of 25 times square root of 2. So therefore this is basically we are doing simplifying root 50. So this equals square root of 25 is 5. So it is 5 root 2. So you can see that instead of root 50, I'm going to put 5 times of root 2. And this becomes, we can now combine these two radicals. So I just put the number first, that is 5, and 17 times of 2. And this equals 5 times of root 35. So basically we have written this under the root of 850 as in its simplest form as 5 root 34. And this quantity basically represents the magnitude of the cross product of r prime of t with r double prime of t. So you can just rewrite this here. This basically r prime of t, cross product of r prime of t with r double prime of t and its magnitude, which we have just found out. Now, if we look at the curvature formula, in the denominator, we have r prime of t, and we have to find its magnitude and cube it. So let's do that now. So first, I'm going to copy this the r prime of t, and this equals negative 5 sine t, 5 cosine t, and 3. So let me do it here. We have r prime of t. This equals negative 5 sine t, comma 5 cosine t, comma 3. So let's find its magnitude. So we find the magnitude of r prime of t, and once again we put this under the square root. We have to do the sum of the squares of the each of the terms, that is negative 5 sine t quantity square plus 5 cosine t quantity square plus 3 square. Now let's evaluate this. So this equals 25 sine square t plus the square of this is 25 cosine square t, and square of 3 is 9. So this is another square root, and we can see that we have this 25 sine square t plus 25 cosine square t. When we group them all, add them together, we factor out 25, and when we do that we'll be left with sine square t plus cosine square t, and this is once again a Pythagorean identity which simplifies to 1. So basically it is 25 times 1 plus 9, and this equals 25 plus 9 under the square root, and this equals under the root of 34. So we have evaluated this magnitude of r prime of t. Now we can find the curvature by substituting into the formula. So let me write the curvature formula, and this equals r prime of t cross product with r double prime of t, we have to find its magnitude divided by the r prime of t. We have to find the magnitude cube. So let's do that now. We will substitute the corresponding values. I'm going to put the numerator as 5 root 34, which we have already found out. So this is 5 root 34 in the numerator. And in the denominator, we have just found out the magnitude of r prime of t, which equals root 34, which we will substitute for the denominator. But this has to be cube. It is a quantity cube. So I put this as quantity cube. Now let's simplify this. So this equals, we have 5 times of root 34 in the numerator divided by, when you cube a square root quantity, let's suppose that we have root a and we have to cube this, and this equals, we have to multiply the root a with itself by 3 times. So it's basically root a times root a times root a. So when you do that, the square root a times square root a is basically a, and then we have 1 square root a. So it's basically a times of root a. So when we use this form, we have a square root of 34 cube. So here a equal to 34. So when I use this simplest form, I can put this as 34 times root of 34. And this means we can just cancel these two root 34. And so finally we are left with this curvature in terms of fraction as 5 by 34. This is if we have to write the answer in terms of fraction. This is the quantity, and this represents the curvature of the helix. Or if we write down this in terms of fraction, we see that this approximately equal 0.1471, 0.1471, and this is rounded to 4 decimal places.